looking legit today at Mr. Hansen 414, and today we're going to do a geometry lesson on angle measures and angle bisectors. Now, I'm going to warn you right away, a lot of this stuff is expecting that you have a compass and a protractor, and I'm not going to make that assumption because what normal person has a compass and a protractor at their house? You probably don't. If you do, great, you can do some of the other stuff. I'm not going to teach that on here because I don't have one that is going to let me hold up the, on there. I'm going to use an online one though. So if you want to learn more about it, you can ask me questions. I can go over it later, but for now I'm just going to focus on the online aspect of all of this. All right, so now that you're here, let me show you a little bit what this is going to look like. So in your book, it's 1.2, angle measures and bisectors. So get there and let's get started. So you guys, the big idea today is the essential question, and that's how is measuring an angle similar to and different from measuring a line segment. So keep that in your mind, highlight that. That's really what we're going to want to come to at the end of this, is know that you can answer that question. All right, so this part here is all about the construction of your angle. So if you had a compass and a straight edge, which can be a ruler, a phone, anything, an index card, you can create your straight edge. You can create these rays. You can create these diagrams to draw an arc. Again, I'm just not going to do that right away. So let's start with explain one, naming angles and parts of an angle. So that's what you're going to be doing today, is naming these angles and making sure you know the parts of them. So there's a couple vocab words. Make sure you get those down. I always like to have a picture to go with them. So once you figure out what they are, I'd add an image. So angle, vertex, and sides. So the rays make the sides. The angle is, in between the two rays. And the vertex is the intersection point. Looks like a V. All right, so the first example we have is, hang on, I need to pause this real quick. Had my capture screen carrying over, so didn't want that. All right, so we have the angle PQR. So that's its name, just like your name's important. The angle, the names of angles are important as well. The middle letter is the vertex, so that's definitely something you want to make sure that you understand. So the middle letter is always going to be the vertex. Make sure you got that down. So in this case, you can clearly see that the rays with the point P on it and the ray with the point R on it, and again, this sketch tab is not going to let me make super straight lines. The angle is in the middle, so this is where your angle would be. So the sides are named QP, quarter pounder, QR. Kind of sounds like virtual reality, but it's not. So that's the basics. So if we look at the next one, you have ray, L, ray with L on it, ray with J on it. So you have KJ, and you have KL as your rays. You with me? Okay. Your angle is going to be, in the angle measure anyways, is going to be in here. And you can also name it angle 1 because that 1 is on the inside. So there's two ways to name it, and you can name it with the letters as long as you make sure that, it's going to be L, K, J, or it's going to be J, K, L. And why is K in the middle on both of them? Because K is the vertex. Make sure your middle letter always corresponds to the vertex. And because the angle has a number on it, that can also be its name. And that's really what these little boxes were for. So if you have any questions, make sure you ask them. Let's keep it moving though. So take a second and pause real quick and do number 3. If you didn't see the diagram for MKG, is there a name that you could give it? you should be able to come up with one because K is the vertex, right? So you could also have angle G, K, M, GKM, or MKG, as long as the vertex is in the middle. So we got a little bit of practice. Name angle 2 in as many different ways as possible. So where's angle 2? Let's identify that. Is there a better way than me drawing? Can I highlight? Sorry, my pen tool is not very good at selecting things. There we go. So there's angle 2. I don't like how that looks, but it is what it is. There's angle 2. How many different names does it have? Well, first of all, what do we got to know? You got to know the vertex. And the vertex is going to be angle, or not angle, but it's going to be E. E. So we have AEB, or the opposite way, BEA. Those are our two angles. You got it? Great. 5 asks you to use the compass and straight edge to copy BEC. Can I clear all this? Or erase it? There's my eraser. If you were to look at BEC, that would be this angle here. So you could, something that we would do in school is use like patty paper. It's like translucent. It's like it gets stick to like burger patties, and you could trace it that way. So that's explain 1. Look at it. Did you learn how to name an angle? Do you know the parts of an angle? If so, we did it. All right, back to it. So we're now on explain 2, and we're going to talk about measuring these angles that we now know how to name, and that we now understand how to figure out all the parts. So to measure an angle, we're talking about the distance around the circular arc. An arc, you know, think of like the outside of a circle. If you chop it up, or like a pizza crust is an arc. So when people say triangle, pizzas are triangles, they're really not. Degrees are the most common measurement. You should know that a circle, 360 degrees. So you can use that to find your angle measures. So if there is 1 degree, that's 1/360th of a circle is what this is explaining. And the measure of the angle is really, you just throw an M, a lowercase m in front of the angle name. We got the 4 types. We got acute angles, which I'm guessing none of you are those. We got right angles. I'm always right. We got obtuse angles. And we got straight angles. So those are the 4 types of angles. Make sure you know each of them. I would draw a diagram of them. Now these, if you can't read this, this is a compound inequality. And this compound inequality says that the measure of angle A, so there's angle A, so the measure, the arc measure, has to be greater than 0, so it cannot be 0. And it has to be less than 90, so it cannot be 90. But it can be anything in between. So it can be 0.0001 degrees all the way up to 89.9999 degrees. But in bigger or smaller, it's not an acute angle. A right angle, the measure of angle A, has to be 90 degrees, and you should be familiar with those from Pythagorean theorem and different things like that. Obtuse angles, so you get a little large. I think all of us are getting a little obtuse during this COVID-19, adding the 19, you feel me? So the measure of this angle, angle A, has to be bigger than 90 and smaller than 180, but it cannot be 180, it cannot be 90. That's also a compound inequality. I think I got a video for that. Straight angle is just a straight line. That's 180 degrees. You should be able to figure out what that is. So let's keep going. Now, I found a protractor tool online for Chrome. I don't know what student Chromebooks are capable of, and I don't want to make that assumption. So I will diagram this. If you happen to have a real life protractor, go for it. But I found this one, and I think it's kind of cool. It's kind of translucent. I've only messed with it for a little bit, so we'll see. So theoretically, let me just test it out, right? if I was going to do what this said, I drew the straight edge. So you can draw a straight edge by just drawing like drawing lines, right? So like draw your line. If you're using a keyboard, shift snaps your lines down. So there's my line. You know, I can draw my points on there. This is not going to be as pretty, I don't think. But I can do this. That book ain't got nothing on me. It's got to be array. So XY. I made XY. Look at me. Look at me go. Now, place your protractor on point X is shown. Locate the point along the edge of the protractor. That corresponds to 53 degrees. So we need to figure out what 53 degrees is. So they did that here. So what they did is they took their protractor, and you would do this in real life with yours. And they figured out here, and mine is very precise, and it's a computer screen, so it's probably not going to be exactly, but there we go. There's 53 degrees. So now what I can do with that, and I'm going to hope that this works. So let's see if this lets me draw on it. It's not. So I would have to extend this out and draw it like this, which is still not perfect, but it would be that. So if you're using this, you have to make your rays extra long. Otherwise, you cannot draw right on top of the protractor tool. If somebody has a better protractor tool, I'd love to hear from you. I just did a quick Google search and called it a day. But so I would just extend my ray like that. And now remember, rays have arrows at the end, because rays go on forever. Like the sun rays, they come all the way this way just to lighten up your face, get that vitamin D. It's supposed to be nice today. So I'm going to go outside at some point. Make sure you do too. Today is Wednesday, by the way, for me. Wednesday the 16th. Feliz Independence Day for Mexico, by the way. All right, so we drew this angle. Now take note how the annotation is. We got the measure of the angle. So the measure of the angle, we have to make sure that we label that. And now you could mark it as 53 degrees because that is the measure of that angle. And we figured that out with the protractor. And if you don't believe me, line it up. There you go. Make sure that you always line your protractor up with the zero, with the origin, and a flat line, a straight angle, a straight line. So make sure that you guys are paying attention to the naming convention, because if you name an angle wrong, like let's say I accidentally put ZYX, that's a whole different angle. Make sure you understand what you're doing with that. Let's keep it moving. So let's do this. Now again, you might be limited with your tools, so I would just say do your best guesstimate. So I'm going to draw this. I'm going to use my shapes tools. There are some drawing things too that you guys could probably use. So I'm going to use shift to snap it down. So I'm going to draw a ray, AB. So if it's a ray, it's got to have an arrow on it, right? And it's got to have 2 points, A and B. So let me get those on there. There's my A point. There's my B point. We're moving. All right. Now it says place your protractor on point A so that AB is at 0. So what they want you to do is make sure that that lines up on the 0 line is straight. So we did that. Now locate the point along the edge that corresponds to 138 degrees. So it's 138. If I remember my 4 types of angles, that's got to be obtuse because it's bigger than 90 but smaller than 180. So I'm going to bring that thing over here. I'm going to find 138 to the best of my ability. If I'm off by a couple tenths, I'm not going to trip. So I'm going to say that's what it is. So now my job digitally is to make sure this is accurate. I'm going to drop a point. Oh, hang on. I think I got to click on my coloring again. So I'm going to drop a point, drop a point, drop a point, drop a point. Why is it not letting me drop a point? There we go. Then I had to go way out there. So this is going to be off. I can already see it's off. I think it might just be like the way this page is oriented, but it's going to be close enough for me. So I'm going to pull this away. Now, I got to use my straight edge to get that other ray in there. So A to, I'm supposed to label that C. So A to C, that's my ray. And I'm going to extend that out. Now I can use my protractor to double check and verify that I did it right, and it's a little off because I obviously made a mistake. Now you see how such a small mistake, because it didn't look that much off. can change your angle quite a bit. Like I'm already off by 2 whole degrees, and that might not seem like a lot, but think about anything that requires precision, anything with a projectile, anything with like orbits or planes or anything that you need absolute precision. A little bit can mess you up. So I do need to draw that my angle measure in. So I'm going to draw that in though, and bam. And we know that the measure of angle cabs are here, 138 degrees. So I know I'm talking a lot today. This stuff's just kind of tedious, so let's just keep it moving though. All right. So reflect. Anytime you see a reflect question, I think it's just a good idea for you to pause and like really just think about it. See if it's gonna like enlighten your brain a little bit. So can you use a protractor to check the angle you constructed? Well, you measure it. You measure the given angle. You measure the constructed angle. They should be the same. That's pretty obvious. Your turn. So if you happen to have a protractor, go for it. If not, let's just classify these. So like 7, what type is that? It's got to be acute. Looking like me out here. Now this one, I'm not too sure, right? Like I can definitely see, I'm going to go with my gut that's not acute. If it was right, it would probably be marked. So it's got to be obtuse or right? So I'm going to guess obtuse, but unless I measure with the protractor, I'm not going to know. So let's measure. So I got to get my protractor in here. I got to line it up on the vertex. I'm going to swing this around. And that's about 40 degrees. So I'm going to write that. The measure of angle MNP, or the other way around, is 40 degrees. I'm not digging this green today, by the way, guys. Now this one's tricky because I don't know if I can orient my protractor. So I would have to reconstruct this, and I don't got time for that. So what I would do, I mean, obviously if I had it in my paper, if it was paper, I would just turn it and be good. And there's probably a way to do that online, but I don't got time for it. So you do that if you got the protractor and let me know. All right, so that was explained too. So let's go back up. Let's see what the goal was. Make sure we can do it. Can you measure angles? Do you understand that they come in degrees? Do you know the 4 types? If so, we're good. All right, so for this one, the constructing part is not going to go well. So I'm just going to try to give you what I can about angle bisector. So angle bisector, vocab word, make sure you know what it is. It's the array. It's an array that divides an angle into 2 angles that have the same measure. So what does that mean? The same measure. Well, it's going to cut it in half. So you're just breaking these angles in half essentially with array. So you have a postulate. We've had a couple of those in 1.1. So make sure you know this guy. The angle addition postulate states if S is in the interior of PQR, so let's make sure we can see all those things. So there's my angle PQR and there's S. S is array. Then the measure of PQR, so the whole angle here, so this is PQR, is equivalent to the angle measure of PQS plus the angle measure of SQR, which makes sense because if you take a whole angle of any measure, say 95, 96 degrees, let's be smart, and we cut it in half, you're going to have 96 divided by 2, which is 48 degrees plus 48 degrees. So if you bisect an angle, the 2 parts on the either side will add up to the same one. So that's the whole gist here. I'm going to try my best to explain these things. However, we're limited because we're not in front of each other and not able to construct these, and I don't think construction is all that important. Anyways, here we go. So looking at this, if you had a compass and a straight edge, you could definitely construct this. So you would take your compass, you'd make an arc. Then you'd plot, you put your compass point here, you'd make another arc. You'd put it at Q, you'd make another arc. You draw the ray through. This ray right here, this ray that extends from the vertex out, so MR, so the ray, MR, you see I'm trying to be real precise with my language. That's math practice 6 at 10 to precision. Is the bisector. That's the angle bisector. And that's going to break PMQ into 2 equal pieces. And then you could confirm that, right? If you had 27 plus 27, you get 54 degrees because that's what we're talking about the whole time. So that's the whole idea. That's the whole idea. If you could fold paper, so think about that, like butterflies, airplanes, that makes sense. If you happen to have it, go for it. We don't. I'm not going to make that assumption of you. That'd be rude. So, any of this important? Well, a segment bisector divides a line segment into two segments, and an angle bisector divides the angle. Duh. Good on that. So practice time. I'll scroll through this real quick. I do want you guys to do, I'm not going to give you, I want you to do 4 and 5. Just name those angles differently. I want you to do 6 and 7. So name each angle in as many ways as possible. So practice. Make sure you don't forget about the vertex, guys. Not tripping about that. I mean, if you have it, go for it. 15, 16, use the angle addition postulate. So that's what we talked about with the whole bisecting. You can add angles together as long as they're bisected. So work on that, and the protractor is already there for you. 20, 21. This is going to require you to set up equations, so make sure they're balanced. Think about it. This is going to be fun for us to talk about, so I'm assuming there'll be questions. Make sure you're ready for those, but I want an effort first. 22 is cool. I'm going to say 22. The next couple are more of like challenging, so like if you're interested in earning an advanced at some point, these are the type of things you're going to need to do to apply the knowledge and concepts to like actual problem, critical solving things. And when you're doing this, guys, models. Like if you want to draw pictures, you want to show the angle bisectors, like draw these things, even if it's not super precise because you don't have your tools, you can still draw pictures. 23, you should try this one. And 25. So again, during all this, guys, any of the time we're working on this stuff together, make sure that you guys are pausing. You're taking notes. I'm not perfect. I'm not pretty good. But, you know, maybe I didn't explain something great and you need a little more follow-up. I'm here for that. Let me know what you need. But you guys got to make sure there's questions. Now, just do this stuff in your book. If you want to do the practice separately, I'm fine with that. But you can also just do it in the book. I would make sure that you're taking out the important information and the important examples and putting them into a notebook of some sort. So you have like my module 1.1 this, 1.2 this. Like I'm trying to like show you the big ideas with the explains and the essential questions. Speaking of which, let's talk about that essential question real quick. Let's go side by side. My face looks big on this one, but so how is measuring an angle similar to and different from measuring a line segment? Well, you measure angles in degrees using arcs, and you measure lines using inches, centimeters, using a ruler. You use a protractor to measure angles, and you use like, I just said a ruler. So that's the difference. Make sure you know that. As long as you're collecting all these big ideas, you'll be okay. Yeah, so I think we're good, guys. Talked about a little bit of compound inequalities. I'm really interested to see how you guys do with the equation part. Other than that, thanks for tuning in. I didn't split this up into 2 parts, and I think that's okay for this one because this was kind of a clunky lesson. So you've been here for like 23, 24 minutes. Thanks for rocking with me. So hit that subscribe button. I'll see you guys later.